So, welcome to Naming Lecture 2. In Naming Lecture 2, I want to focus on the polyatomics, and we're going to focus on acids. So to start with, let's start by looking at polyatomics. For polyatomics, we need you to memorize 6 of them to start with. In 121, we're going to have you memorize a few more, but for this class right now, let's memorize 6 of them. The only one that we want you to memorize that's positive is ammonium, which is NH4+. Has a +1 charge, and it's named ammonium. I would strongly recommend note cards and flashcards and practice these. The first negatively charged one we want to memorize is hydroxide, which is OH-. And then there are 4 8s that we're going to memorize. 4 8s. They end in -ate. When you take Chem 121 next quarter, we'll talk to you about how we convert the 8s to ites and per-8s and hypoites. But for this class, we're only going to deal with the 8s. So the 4 8s that we want you to learn are nitrate, which is NO3 -1. Carbonate, which is CO3 -2. Sulfate, which is SO4 -2 charge, -2 charge, which is sulfate. And phosphate, which is PO4 with a -3 charge. And if you look closely, the nitrate and carbonate both have 3 oxygens and they go up 1 charge. The sulfate and phosphate both have 4 oxygens and there's a 1 charge difference between them. It's really important you kind of have these memorized and can recognize them on sight. They get used in naming a whole bunch because chemists are lazy, and we repeatedly find these compounds over and over again, these polyatomic ions in compounds over and over again. So naming is pretty straightforward. For instance, if I tell you I have sodium sulfate, that means sodium is Na, sulfate is SO4, and we know that sulfate has a -2 charge. When we look sodium up in the periodic table, it has a +1 charge. So in order to get this to balance out, we're going to need 2 sodiums to go with the sulfate. So it's going to be Na2SO4 for sodium sulfate. We can also make you go the other direction. We could give you a compound, for instance, PbSO4. To name this, you might think, and I know students do this all the time, that this compound should be called lead sulfur oxide or oxygen, right? That actually is a completely wrong name. It's bad. No, no, no. We got to really think about this a little bit differently. First thing we realize is we have lead, which is a polyatomic, so I need to look at what it's bonding to. Well, it's bonded to sulfate, and sulfate we know has a -2 charge, so the lead must be a +2. So to name this properly, we're going to have to name this lead. Because it's a transition metal, we're going to have to put the Roman numeral 2 after it. And then the sulfate, or the S and the O4 is going to just be simply sulfate. It actually will make your life much easier in the long run if you learn these, because lead 2 sulfate's a lot simpler than lead 2 sulfur oxide to write out. Plus, how many oxygens are there, right? Does that make sense to folks? Because when we get to later on next quarter, the ites and the per-8s, we actually change the number of oxygens in these compounds. The other thing I briefly want to talk about is the book does get into a little, and you will see from time to time, compounds like NaHCO3. In this case, I have actually 5, 6 elements there, but I know that CO3 is carbonate, I know that Na is sodium, and the H actually in this case we just call hydrogen. So this is actually called sodium hydrogen carbonate. Sometimes in the old school naming system this would actually be sodium bicarbonate. And then lastly, acids. Acids are going to give a dead giveaway. Acids almost always start with an H. There's a few that don't, but for the most part for this class they will all start with an H. So if you see a compound starting with an H, I guess the big exception I should say is water is not considered necessarily an acid at this point for you guys in class. Actually water can be both an acid and a base. But any other compound that starts with H's, you must normally are going to end in the name acid. So for instance, HCl is hydrochloric acid. HBr would be I left out the R up there in chloric. Sorry, hydrobromic acid. And then if you have an H in front of one of the polyatomics that we have up there, particularly the 8s, they become the ic acids. So for instance, HNO3 looks like it should be hydrogen nitrate, but it's actually nitric acid. H2CO3 would be carbonic acid. H2SO4 is actually sulfuric acid. H3PO4 is actually phosphoric acid. Again, we hope these lectures help out. Let me know if they are helpful to you. Again, I'm trying to add some more into the class as we go along. Have a great day, and always feel free to ask me lots of questions. Bye.